Hi. Uh, you had a few questions about functions and polynomials, and I'm going to try to answer them the best way I can. Uh, so, your first question was, are there steps to solving these? And my answer to that question is that what you were looking at did not involve any equations that needed to be solved. Um, so you don't solve, and the reason is because you can't. Okay. These aren't solving. These are expressions to be simplified. And simplified just means put together what you can. So these are expressions to be simplified, or they are functions to be analyzed or evaluated. Okay? So, and it's going to depend on what we're talking about. Okay? So let me sort of take you through stuff one at a time. A function. Let's talk about what a function is. A function is a y equals or an f of x equals equation with only one answer. So the difficulty lies in looking at them in different forms and deciding, can I get it in a y equals format, and will it only have one answer? For example, if I give you like an x equals 7 equation, that is not a function because there is no y equals. There really is no y in this equation at all. So it's not a function at all. If I give you, let's say, a y squared equals 3x, this one you would need to solve, and to solve it, what you would do is you would take the square root on this side and plus or minus the square root here, giving you y equals plus or minus the square root of 3x. And this right here is two answers. So this one's not a function either because of that. Okay? So if you solve it for y and you get more than one answer, then you're talking not a function. If you get y equals some stuff when you solve it, any stuff at all, as long as it's only one answer, that is a function. Okay? Let's talk about multiplying two polynomials. Okay? When you're talking about multiplying two polynomials, and I'll make one up here. Let's say we have 3x to the fourth minus 7x squared plus 4 times 2x minus 3. Okay? You had a question about whether this was a minus or a negative, and the answer is that it represents both. This can be rewritten, as you kind of did, as plus negative 7x squared. So minus and plus negative. Minus and plus negative are the same thing. And I do encourage you to write every minus as a plus negative. Okay, so I'm going to write each minus as a plus negative there. The next thing is that you're going to take this one over here, and you're going to distribute it, that is, multiply it, by each part of this one. So that's going to come out looking like this. If I take the 3x to the fourth, and I multiply it by the 2x plus negative 3, then I've done this one with this, okay? Then I'll put this plus, and then I'll do this one plus all of this. So that's negative 7x squared times, did I say plus? I meant times, sorry. Times 2x plus negative 3. And then that plus goes right there. And then the 4 right there, times all of this again. So times 2x plus negative 3. And that equals, and then you have to do all these smaller distributions in here, all these smaller multiplications. So you do 3x to the fourth times 2x plus 3x to the fourth times negative 3 plus negative 7x squared times 2x plus negative 7x squared times negative 3 plus 4 times 2x plus 4 times negative 3. And then you have to figure out what the answer to each of those is. So let's do this one. I'm going to do multiply 3 times 2, and 3 times 2 is 6, and I'm going to multiply x to the fourth times x. So there are 4 x's being multiplied here, and you were right on that also. 3x to the fourth, I'll do it down here and then get rid of it, does indeed mean 3 times x times x times x times x, 4 of them. And so that's this one here. And then if I multiply it by another x, then I'm talking 1, 2, 3, 4, 5 of them. Okay? So this would come out to x to the fifth, because as we just counted, there would be 5 of them. So that takes care of that one. Okay? So then this plus goes in between, and we'll do 3 times negative 3 Positive times negative is negative, and 3 times 3 is 9. Let me write a better 9 there. One more time. There we go. And then I've got this x to the fourth, and notice that in this whole thing here, there are no other x's. So this is just negative 9x to the fourth. Let me write that 4 a little bit better. And that takes care of that one. Okay, then this plus, and let's do that multiplication right there. Negative 7 times 2 is negative 14, and x to the second, which means x times x, that is 2 of them, times another x makes 3 of them, or x to the third. Then this plus, and we'll multiply these two, and negative 7 times negative 3, a negative times a negative is a positive, and negative 7, and so negative times negative is positive, and 7 times 3 is 21, so I get a positive 21 from that, and then I'm left with this x to the second, which there is no other x's to put it together with, so it's just x to the second. That plus right there is that plus right there. And we'll do this one. And so we want to do 4 times 2, which is 8. And there's an x still there. This plus becomes that plus right there. And 4 times negative 3, positive times negative is negative. And 4 times 3 is 12, so we get negative 12 right there. So I've taken care of that one, that one, that one, and that one. Now, every plus negative here could be turned back into a minus. So we could be looking at 6x to the fifth minus 9x to the fourth, because this plus negative means minus. And then there's another plus negative, so I can write that as a minus 14x to the third plus 21x to the second plus 8x. And then I've got another plus negative here, so I can call that minus again, and minus 12. Now, because these exponents, these powers, are all different, what that means is this is as much as I can put it together. So that is actually my final answer. There's no way of putting it together more than just that. So I hope that helps on that question. The degree of a polynomial, I'm going to make polynomial shorter that way. The degree of a polynomial is the highest exponent that you see in the polynomial. So if I gave you something like 3x squared minus 7x to the fifth plus 4x to the third, that would be the degree, so the degree would equal 5. That's the degree of the polynomial. The leading coefficient of a polynomial, and I'll have the same one here, is the number attached to the degree. That is to say, the coefficient. So let's rewrite this a little more carefully. I'm going to take this minus and I'm going to write it as a plus negative. It's, in my opinion, it is always a good idea to do that. And what we're going to see is, okay, so there's the degree. The number attached at the front, is -7. So the leading coefficient is -7. Okay, so I hope that helps with that one. When you are asked to evaluate, so if I give you a function f of x equals 3x to the third minus 4x squared plus 5x minus 7. I'm just making one up here. If I ask you for f of something, let's say I ask you for f of 3. What I'm asking you to do is, and this will be easier if you put parentheses around every x and replace these parentheses with these ones. In other words, all the x's become a 3. So 3 parentheses 3 to the third. I'm going to take this minus, I'm going to turn it into a plus negative. 4 parentheses 3 to the second plus 5 parentheses 3. This minus I'm also going to turn into a plus negative. And 7, notice on this 7 there are no x's, there are no parentheses that I had to add in, so there's no 3 there. So then f of 3, and that's how you read it, f of 3, is 3 times 3 to the third. Let's have some side work here. 3 to the third means 3 times 3 times 3, which is, if I put these two together, that's 9 times 3, which is 27. So 3 times 27, plus -4 times 3 to the second means 3 times 3. So 3 to the second means 3 times 3, which is 9. So that's -4 times 9. Plus, and then this 5 times 3. 5 times 3 is just 15, so there's no extra work to be done there. And then you can figure out 3 times 27. If I do 27 times 3, that's 3 times 7 is 21. Carry the 2. 3 times 2 is 6, 7, 8. So that is 81. Plus -4 times 9, negative times positive is negative. And 4 times 9, it turns out, is 36. Plus, and then I'm going to combine those two because there's nothing else to be done with them at this point. And 15 plus -7 is like 15 minus 7, remember? And 15 minus 7 is 8. So plus 8. And then I might want to figure out maybe some more side work here. What is 81 minus 36? I'll borrow, and that'll be 11 minus 6 is 5, and 7 minus 3 is 4, so that's 45 plus 8. And 45 plus 8, if I do that real quick, 5 plus 8 is 13, carry the 1, 8, and then 4 plus 1 is 5, so this is 53. So f of 3 equals 53. Okay, so that's that one. A polynomial in one variable has two things. So polynomial in one variable has two elements. One has to be a polynomial. And how do you know that it's a polynomial? So here are some things to look for. No x in denominator, that is in the bottom of a fraction. There's no x's in the bottoms of the fractions. If there is, it's not a polynomial. The second thing to look for is no square roots of x or even other roots of x. And the third thing is all exponents have to be whole numbers. So they have to be 1, 2, 3, 4. You can't have a half as an exponent. You can't have 5/3 as an exponent. You also can't have negatives as an exponent. Okay? Any of that disqualifies it from being a polynomial. The second part of being a polynomial in one variable is that it has to have only one variable letter. That is, it only has one letter involved. It might have different exponents and stuff like that, but it can only have one letter. If you get an x next to a y, or even if you get, like, if I had 3x squared plus 2y, not a polynomial. Okay? Or, well, it is a polynomial, but not a polynomial in one variable. Okay? So that's a polynomial in one variable. Finally, the last thing on the quiz that you were looking at, this is quiz 6-3, it asks you to find f of x plus h for something for, and I'm going to make up an f of x here, for f of x equals, excuse me, let's say x squared minus 7x. So what that means is put parentheses around every instance of x and replace it with x plus h. So then you get x plus h with a power of 2. Minus, I'm going to turn into plus negative, and parentheses, and instead of just x, it becomes x plus h. Now the question is, how do you do this? Because you should know that this is just going to distribute. So how do you do that should be the real question. Well, x plus h squared, emphasis on the squared, means you're multiplying the thing by itself. So it's this thing times itself. We can do this distribution here at the same time. Negative 7x plus negative 7h. And then I'm going to take this and I'm going to distribute it to both parts, multiply it to both parts of that. So then I'm going to have x, that means that x, times this whole thing here, x plus h, then this plus h, that h, times that whole x plus h, that one right there. And then I'll just tack on the plus negative 7x plus negative 7h onto the end of it there. And then I have to do those distributions right there. So I've got x times x, which is x to the second, plus x times h, plus that plus right there, at h times x, which I can also write as x times h if I want to. I could write them as hx too, plus h times h, which is h squared, plus negative 7x, plus negative 7h. Those aren't changing at this point, or actually we're going to see that those will never change. So x squared, and now look at this. I've got an x plus h and another x plus h being added together. That means there are two of them. So x plus h, or xh plus xh is 2xh, plus that h squared plus negative 7x. I'm going to change that plus negative back into a minus. And I'm going to change this plus negative back into a minus. And I can't put it together any more than that. So that winds up being my answer. So this has been your help for Quiz 6-3. I hope it helps you. Thank you.